Welcome back. We are talking about permutations and probability. The next thing we want to look at is permutations with repeats. And what that means is that you still have a number of permutations. So we want the number of permutations of n objects where one of the object is repeating or more. So we have one of the objects, we call it repeats x sub 1 times. So you have something that has a certain number of repeats. You also could have more than one. So you might have another object, and this is going to repeat some x sub 2 number of times, and so on. All right, so I could have, more objects that are doing repeats. So the number of ways that we are going to be able to change around these permutations is going to be given by n factorial divided by the factorial of all of the repeats. So every repeat gets its own factorial in the denominator. And that's going to tell us the actual number of ways that we could rearrange the objects or take the objects. What we call those is we call these distinguishable permutations. And the reason why we call that is because you have to be able to consider that a letter, if it's repeating, has multiple ones, that it's an individual letter. So let's look at this. I want to find the number of distinguishable permutations. Well, that's a mouthful. All right, so the number of distinguishable permutations of letters. All right, so we're going to do two of them. Okay. So the first word we're going to look at is the word soccer. Okay. So to figure out the number of ways that we could rearrange these letters, first the numerator has to be the total number of letters in the word. So 1, 2, 3, 4, 5. There are 6 letters in the word, so my numerator will be 6 factorial. There are 6 objects. Now, any letters that repeat are going to go in the denominator. So I have the letter C that repeats 2 times. Since no other letters repeat, I don't need to write any other denominator factorials. So what I'm going to do now, again, is I'm going to expand out the numerator, and again, stop when I get to the same factorial as the denominator so I can cancel out. And when I put that in my calculator, I have 320 ways, again, to be able to rearrange those letters in the word soccer. Now, what if I have a word that has more than one letter that repeats? For example, Tallahassee. I have lots of repeats in this one. So again, let's count the letters in the word. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 11. Now in the denominator, I need all of my factorials that are repeats. So I just kind of go through the word. T is no repeat, but the letter A repeats 3 times, so that's a 3 factorial. The letter L repeats twice. The letter S and the letter E. So every one of those repeats needs to be expanded. And now this is going to be a lot of expansion here, but that's okay. If I think about starting this off the same way, then when I get to this 3 factorial, I know that's going to cancel with this 3 factorial. But I'm going to need to expand out these other factorials as my other factors to see what's going on. So the 3 factorials are going to cancel. Right? Obviously, I don't care about the ones, but now I can think about just how to simplify fractions. This 2 and this 2 create 4, which means I can cancel out that 4. This 2 can go into the 6, 3 times. And so now I'm really going to just multiply this numerator out, these 11, 10, 9, 8, 7, 3, and 5 to get the total number of ways. And so with all these letters, I can change them around 831,600 different ways.